In this video, we'll discuss solids and surface area. Now let's start with the idea of what is a polyhedron. This is a three-dimensional figure whose surface is made up of polygons, which means we then have faces, edges, and vertices. The faces represent all the polygons that make up its outer surface. The edges are where two of those faces come together to form a segment, and the vertices are the point where multiple faces come together. So when we look at shapes, we want to determine, is this a polyhedron or not? So if we look at this solid that's provided here, we'd say, yes, it's made up of rectangles. This is a rectangular prism. And we can then count the faces, vertices, and edges and see that there are 6 rectangles that make up this shape. So we'd say there are 6 faces. There are 12 edges, or 12 segments, 4 on the top, 4 on the bottom, and then 4 vertically that connect the top to the bottom. And then 8 vertices, 8 points that we see that go around to make up the solid. Here we have what's called a triangular pyramid. And again, this is made up of triangles which are polygons. So yes, this is a polyhedron. And we'd say that there are 4 faces because there's 4 triangles that make up the shape, 6 edges because there's 6 segments that we go around to make it, and 4 vertices, 3 on the bottom and 1 up top. Last shape here is what we call a cylinder. And this would not be a polyhedron because circles are not considered polygons. But it is a solid. Now, when we have polyhedron, what we know is that we can actually calculate the vertices, the faces, or the number of edges if we have 2 of those 3 pieces of information. Because what Euler determined was that the number of faces plus the number of vertices equals the number of edges plus 2. So we substitute the 2 values we have and find the third. So if a polyhedron has 6 faces and 8 vertices, we want to know how many edges does it have. So we can substitute in our values. Faces plus vertices equals edges plus 2. And then we can subtract the 2 from both sides and say that there are 12 edges, which goes back to the shape of our rectangular prism. In this example, we say that if a polyhedron has 4 faces and 6 edges, how many vertices does it have? So again, we substitute in the values we have. We have the faces and we have the edges, and we're solving for the vertices. So here we have 4 plus the vertices will equal 8. Subtract 4 from both sides, and the number of vertices has to equal 4. And that gets back to our triangular pyramid. Now, a prism is a polyhedron whose bases are congruent and parallel to one another. And that's a key part to recognize here when we're talking about polyhedron. So when we talk about the base, though, it's the 2 polygons that form the shape that spreads out to make the prism. It does not have to be the bottom of the polyhedron or the solid that we have. The base can be the left, the right, diagonally, as long as it is the shape that's being stretched out to make the prism. And then everything else that we have is called a lateral face to that polyhedron. So if we look at our solid here, we want to determine what's the name of this prism. The first thing we have to do is identify what is the base. And the base tells us the name of the prism. And so we look here and say, what shape is being stretched out? Okay, and there is no true bottom to the shape, but the base is the shape that is being extended out. And what we see here is it's really the triangle. It's that triangular prism that's appearing right here, and it's stretching backwards. In this solid, if we look at this polygon, we say, well, here, what I see that's being stretched out from top to bottom is a pentagon. So we call this a pentagonal prism, or a pentagonal prism, depending on how you want to say it. Now, a cylinder is not a polyhedron. It is a solid, but it is a solid where we have the congruent circles that are parallel to one another. And we can have both right cylinders and oblique cylinders. The right ones are what we commonly think of like soup cans, and oblique is where we can actually turn it diagonally, but we still have the 2 circles parallel to one another. Now, cones and pyramids are comparable solids, except that a pyramid will be a polyhedron because it's made up of a polygon base that then the faces meet at an apex, whereas a cone has a base that is curved, often a circle or an oval, and then it goes to this apex point. So if we look here, we'd say, well, our base is a triangle that then meets at a point, and we could say it's the bottom side, we could say it's this side, or even this front side. They both taper to an apex either way you look at it, and it's always going to be a triangle that is the base of that shape. Here, if we look, what is the primary shape that's then tapering? we see that it is this pentagon. So we would call this again a pentagonal or pentagonal pyramid. And lastly, we see we've got here a base that is circular in nature, and we would call this then a cone. Now, we use the idea of the surfaces, of the faces and the solids to understand how to construct surface area. And surface area is all the area of the surface of a given solid. Now, we can represent that surface area with a net, which is a 2D representation of the surface area for the 3D solid. The idea is that if you take your solid and you peel it away and lay it flat on the ground, you would have all the parts that make up the surface area, and then you can look at it as two-dimensional shapes. So here is the representation of a pentagonal prism on the left, and if we peel it down to its net, we have the shapes here on the right. Now, how can we determine then the surface area of a solid? We have two options that are most commonly used. One is you can memorize and apply formulas for a given solid. Most solids that we will work with have formulas for how to calculate the surface area. When you do this, you have to recognize what are these letters that you see in the formulas. A capital B means the area of the base, not just the length of one side, but the entire area of the base making up that solid. LA is going to represent the lateral area, which is the area that does not include the base. The capital P will represent the perimeter of the base. A lowercase h will represent the height, and then a lowercase l will represent the slant height. And then we have typically these 5 formulas that we will work with. For a prism, a cylinder, a pyramid, a cone, and a sphere. These will often be given to you on formula sheets. But you do have to recognize what these letters mean as you go along. The other method for finding surface area is that we can just create the net. Once we have the net, we can calculate the area of each of the two-dimensional shapes that make up that entire net. And then the additivity principle allows us to add all those areas together to get the total surface area. So let's try both of these methods on a couple different solids. Here we have a rectangular prism, and let's determine the area. If we want to find the area of this prism, we would say that it's the area of the base times 2 plus the perimeter times the height. Well, we have to first say, well, what is the base? So we would say in this case probably that it is the bottom side. It doesn't have to be, but in this case it's probably an easy one to use. So we'd say we're going to do 2 times the area of that base. Well, the capital B, the area of the base, would be the length times width. 6 centimeters times 4 centimeters, which is 24 square centimeters. Then we need also the perimeter. The perimeter would be adding up the 4 sides. And often with perimeter of a rectangle, we say it's 2 times the length and 2 times the width. So 2 times 6 plus 4, which is 20 centimeters. Or you could literally go around 6 plus 4 plus 6 plus 4. And then the height is what extends to make up the other opposite base. So in this case, we would say that's the 8 centimeters. Now we substitute in our values. That would be 2 times our area of our base plus our perimeter times the height. We simplify that and then add our values together and get 208 square centimeters. Now the other option would be to create the net. So we take our rectangular prism and we pull it apart and then look at each of these individually shapes. And all of these are rectangles, which is what makes this so easy to calculate the 6 different areas. So I'm going to calculate them in 2 at a time because it is we have congruent rectangles. So we have 2 of the 6 by 4 rectangles. So I have 2 of the 6 by 4 rectangles. That's 48 square centimeters. Then I have 2 of this 8 by 6 rectangle. So that would be 2 times the 8 times 6, which is 96 square centimeters. And then I have 2 of this 4 by 8 rectangle. So I can double the 4 by 8 and get 64 square centimeters. Now if I add up all of those areas together, I will get that the surface area is again 208 square centimeters. So either method will work to help us determine the surface area. Now say that we want to find the surface area of this square pyramid where we know that the length of each side of the square is 5 inches and the slant height is 6 inches. If we want to use the formula, we would first say that's going to be the area of the base plus 1/2 the perimeter times the slant height. So let's label the parts we have. And it's important to remember that that capital B means to calculate the area. Well, we have a square for our base, So we'd say it's 5 by 5, which is 25 square inches. The perimeter then is adding up the lengths of our sides, or saying 4 times 5, since it's 5 plus 5 plus 5 plus 5. Now we also have to recognize the slant height is 6 inches, because it's that cursive L. So now, substituting our values, 25 square inches plus 1/2 of the perimeter and the slant height, that's going to become 25 square inches plus 60 square inches, which is 85 square inches. Now again, we can also use the net. And at the net, what we're going to do is peel back the triangles and lay them beside the square. And then it would look something like this. And we can label the slant height on all 4 of those triangles to see how do we calculate the area. So the first area we need is the area of that square, which we know is 5 by 5, or 25 square inches. Then we have these 4 triangles. And what we recognize is all 4 triangles are identical. And if we think about how do we calculate the area of a triangle, it is 1/2 the base times the height of the triangle. And base in that one is the lowercase b. And there's 4 of them, so we could say that's 1/2 of 5, because that's the base, times the height, which is 6, because those are the perpendicular sides to the triangle. Well, 4 times 1/2 times 5 times 6 gets us back to 4 times 15 square inches, which is 60 square inches. So then 25 square inches plus 60 square inches, again, takes us to the 85 square inches.